In this demo, we're going to change the title and remove the description of a movie through a partial update. For that, we're going to use the partial update service. It's currently mostly empty, so let's first add a static HTTP client instance. HTTP client is defined in system.net.http, so let's add a using statement by pressing enter. And we also set up some defaults, like the timeout value and base address, just as we did in our CRUD service in the previous module. Then let's add a method, patch resource. What we want to do here is create a JSON patch document, i.e. a change set. But first things first, that JSON patch document is defined in the Microsoft.ASP.NET Core.json patch assembly. So let's add a reference to that. Let's open NuGet. And let's look for the Microsoft.ASP.NET Core.json patch package. And there we go. Let's click install. And that should do it. Note that if you're using ASP.NET Core 2 or higher, you'll already have a reference to this because it's part of the Microsoft.ASP.NET Core.all meta package. Anyway, that takes care of that. In the patch resource method, we can now new up an instance of JSON patch document. That's defined in the Microsoft.ASP.NET Core.json patch namespace, so let's add a using statement by pressing enter. There's actually two ways to go about this. We can use the untyped version, as I just typed, but we can also use a typed version. For example, instead of just an untyped JSON patch document, we're going to define a JSON patch document for a movie for update object. That one's defined in the movies.client.models namespace. The untyped version is mainly intended for dynamic systems, i.e. those cases in which you don't have compile time classes to work on. If you do have those, like we do with our movie for update class, it is better to use the typed version, as it includes additional compile time checks to ensure you don't make mistakes when adding the operations. And that's the next part, adding operations. As we learn on the slides, a patch document consists of a set of operations. On JSON patch document, there's helper methods for this. We see we have a remove method, a replace method, an add method, and so on. In our case, we want to replace something. And as we're using the typed version, we can actually pass through the property we want to replace. In our case, that's a title property, and let's set that to update the title. There we go. And then we want to remove the description. For that, we call remove on the patch document. This will add a remove operation. And what we want to remove is the description, which we can easily access thanks to the fact that we're working with a typed version. And that's our change set to send. What's next will be very familiar. We serialize the change set. For that, we use JSON.NET. Then we create a new HTTP request message. We pass through the method, patch, and the URI of the movie we want to patch. As an accept header, we pass through application JSON. We haven't imported the system.net.http.headers namespace yet, so let's do that by pressing enter. And there we go. The content we're going to send is still a string, so we can use string content again. But the content type is a bit different. As we learned, the correct type to use, according to the standard, is application JSON patch plus JSON. So instead of using application JSON, we will use this standardized type. Then we send the request, we ensure we get back a successful status code, and we read out the content. That's exactly as we did before. So let's put a breakpoint here. And let's make sure we call this method when the run method executes. And now there's just one more thing to do before we can test this. We have to ensure that the dependency injection system provides us with an instance of partial update service when we request an iIntegration service implementing instance. Let's open the program class and scroll down to configure services. Here we registered CRUD service. But this time we want to change that. We're done with the demos from that module, so we want to register our partial update service. And there we go. Let's give this a try. We hit our breakpoint. Let's have a look at the response. We got back a 200 OK. So far, so good. Let's have a look at our updated movie. We see that the description is null, so our remove operation worked. And we also see that the title is now updated title, which means our replace operation has also been executed correctly. That begs the question, is there a shortcut for this as well? Let's have a look. Obviously, there's also a shortcut for patching, and that's what we'll check out in this demo. The first part of the code is the same. We have to create the JSON patch document. After that, we call patch async on the HTTP client. We pass through the resource URI and a new string content object. That's initialized with the serialized patch document, the encoding we want to use, and the media type for the content type header, application JSON patch plus JSON. Then we ensure the request was successful and we read out the response. Note that just like the other shortcuts we looked into in the previous module, here too we run into that request header issue. Headers like accept, accept encoding, accept language and so on are not set on a per request basis. You can only set them at level of HTTP client itself if you want to use this patch async method. Let's have a look at some advanced patch scenarios. Patch and the JSON patch standard allow for much more complicated scenarios as well. For example, manipulating an array. Imagine that the Movies API would also expose a movie's actors as an array. In the example on screen, we're sending a patch request to a movie that will add a new actor at location 3 in the actors array. Now, imagine that such an actor has a property nationality. We could replace that by a new value by accessing the correct actor from the actors array. So, it's a really powerful standard. Yet, from an API point of view, implementing support for this can get pretty complicated pretty fast. Most APIs I worked on tend to allow patch requests one level deep. So, even though you can create JSON patch documents for those complicated operations in the same way as we did in the demo, it's a good idea to first check with the designers of the API whether or not the scenario is supported. Let's have a look at this module summary. We learned that patch is the preferred method of updating resources. Modern APIs don't even necessarily allow put anymore. The body of a patch request is described by the JSON patch standard. In essence, it's a list of operations that have to be applied on the resource. To create such a patch document for use with HTTP client, we can use JSON patch document and related classes. Lastly, patch can be very powerful, but also very difficult to implement from the perspective of an API. Therefore, most APIs will not support changes that go deeper than one level. So, if you're integrating with an API, it's important to check what it allows before creating patch documents. We talked about HTTP content and related classes in the previous module, and we already used the string content class. There are other classes that derive from HTTP content. In the next module, we'll use one of those to support streams. We want to keep the memory footprint of our application as low as possible and the performance high. Streams can help with that. In this module, we'll learn how. We'll start by learning what streams enable. In other words, the advantages of working with streams. Then we'll learn how we can use that knowledge with HTTP client. In the demos, we'll learn how to read data using streams, how to send data, and we'll test the potential performance improvements. We'll end by looking into compression to further improve performance. Let's dive in by learning about the advantages of using streams. What is a stream? It's an abstraction of a sequence of bytes, such as a file, an input-output device, or network traffic. The stream class and its derived classes provide a generic view of these different types of input and output. Like that, it isolates us from the specific details of the operating system and the underlying devices. Important is that we can read from and write to such a stream, depending on the type, when dealing with network traffic and within memory objects. Like that, we don't have to use temporary in-between variables that increase memory use and can hurt performance. Also important to know is that this has nothing to do with streams at API level. Everything you'll learn in this module regarding streams has to do with the client, and it works regardless of the API working with streams or just serializing from memory. An API doesn't need to use streams to see an advantage with using streams on the client. So you can use this with any API, and that's definitely an advantage. Let's have a look at what happens when we call our API. We're only going to focus on the response for now, as we'll start with getting data. So a request is sent, say to get a movie poster, and the response comes in. Due to the nature of HTTP, the response comes streaming in over the wire, whether or not the client or the API works with streams. Those are two different things, as will become obvious soon. When all the content has arrived, we can read it out from response.content. Up until now, we've done that with read as string async. This creates an in-memory string, which is as large as the complete poster response body. After that, we need to transform that string. We deserialize it into a poster object. For this, we use JSON.NET. There's a few things going on here that we can improve. Let's start with that in-between string that's created. Instead of deserializing the object from a string, we can use a stream. That means we no longer need the potentially large in-between string. It doesn't have to be created in memory first. This thus diminishes memory use and improves performance. Let's have a look at how we can do that.